Hey, what's up? I'm going to go over the quiz that we took on Friday in geometry class, and this is problem number 1. And the way I'm going to set it up for all these problems is I'm going to show you the step, and remember, there's always going to be a reason for doing the next step. Okay, so I start out with 9b plus 38 equals 10b. Okay, and the reason is that was what I was given. That's the problem. All right, now, the first thing that I'm going to do try and get down to solve this equation for b, which was in the directions, is I'm going to do something with this 9b. I'm going to get all my b's on the same side of the equal sign. Okay, so the first thing I'm going to do is I'm going to add the opposite of 9b to both sides of the equation, because remember, I need to keep things balanced. Okay, so I'm going to add the opposite of 9b and the opposite of 9b. I'm going to add that. Okay? And the reason is that's the addition property of equality. Okay? The addition property of equality says that I can add the same thing to both sides of an equal sign and I won't change anything. Okay? Alright, so what happens here is it cancels out on the right hand side. 9b plus its opposite is 0. And I'm not going to write the 0 because it's just there. And now what I'm going to do is I'm going to carry my 38 down, because it's still there. It's still on this side of the, if you think of the equal sign like a teeter-totter with kids on it, I still have 38 kids on this side. And over on this side I have 10 minus 9 is positive 1b. Okay, I had 10 b's, and then I took away 9 b's, and I have 1 b left. Okay? Now, I can write the 1b, but in algebra we typically don't write 1 because 1 doesn't change anything when you multiply it. Okay, it's called the multiplicative identity. It means anything times 1 is itself. Okay, so I'm not going to write it. Okay, so I took 1 away, and this was a one-step problem. It's b is equal to 38, or 38 is equal to b. And now you can rewrite that if you want and put b on the left, as is typically done. B equals 38. Now, the reason that you can rewrite it like that and switch the sides is called the reflexive property of equality. And what the reflexive property does is tells you that if 38 is equal to b, well then b is equal to 38. A thing is equal to itself is basically what it means. So that means I can put them on either side of the equal sign and it still has the same meaning. Okay, so the answer to the first one was b is equal to 38. Okay, now I'm going to solve problem number 2. And problem number 2, I have the opposite of 3 times the sum of z and 7, okay, equals 4 times z. And the reason for that is, well, that was given. I was given a problem that said solve for z. Tell me what z is in this equation that makes it true. Okay, so I need to find out what z is through a series of algebraic steps. Each one is going to have a reason for it. Okay, so I'm going to start off here, and I have the opposite of 3, or negative 3, times the sum of z and 7. Okay, now I can't simplify inside the parentheses because 7 and z are not like terms. So what I'm going to do is I'm going to do what's called a distribution. Okay, so I'm going to write that. Okay, and now what a distribution means is I have the opposite of 3 times this sum, so that means I'm going to have the opposite of 3 times z and the opposite of 3 times 7, so I'm going to write that. Okay, if I mess you up a little bit here, where I have the opposite of 3z plus the opposite of 21, go back and watch my video on algebraic addition. Okay, I'm just putting it in there because it's going to help simplify things, and you'll see why in just a second when I go to the next step. Alright, the next thing I need to do is deal with this opposite of 3z, or negative 3z, and I need to get all the z's to one side. Okay, so let's take a look here. I've got the opposite of 3z and I've got 4z over there. So I always want to move the smaller one, okay? The one that's closer to 0. This is 4 in the positive direction. This is 3 in the negative direction. So this 3 is closer to 0. So I'm going to move that to the other side, okay? So I'm going to do the opposite of the opposite of 3, which is positive 3. I'm going to add that to both sides. Okay? And that's called the addition property of equality. Okay? You can add the same thing to both sides. Don't change anything. Okay. So these two cancel. 3 and its opposite. And that'd be 0. I'm not going to write it. I'm going to carry down the opposite of 21. And I'm going to find the sum of 4z's and 3z's, which is going to be 7z's. Okay? Alright, so that's just a simplification. Okay? You can usually write the simplification step, but it's not necessary. Just know that you did it. It's a simplification, which was to add these two and add those two. Okay, now I'm left with the opposite of 21 equals 7 times z. Alright, so now this is 7 times z, but I need to know what 1 times z is. So I'm going to use the division property of equality, which says that I can divide both sides of an equal sign by the same number, and I haven't changed anything. It'll still be true. Okay, so the reason is going to be division property of equality, and I'm going to divide both sides by 7. Okay, so over here, 7 divided by 7 is 1. I'm going to simplify it by just writing z. Again, I'm not going to write the 1z. I'm just going to write z. And over here, the opposite of 21 divided by 7 is the opposite of 3. Okay? So I've got z is equal to the opposite of 3, or I could flip it around using the reflexive property and say that z is equal to the opposite of 3. It means the same thing. Okay? So the answer to the second one was z is equal to negative 3. Okay, here's problem number 3. This says m minus 7, or m plus the opposite of 7, is equal to the opposite of 13 plus m. Okay, and the reason for that is that was given. Now what I need to do is find a solution to this that makes this a true statement. Now, this one's kind of a tricky one because, let's take a look. I have m on this side and I have m on that side. Okay? Now, by the addition property, that says that I could have had the opposite of 7 is equal to the opposite of 13, and then I could have added the same thing to both sides, which would be m. Okay? Do you guys follow? It's kind of a tricky thing. But let's undo that by using the subtraction property and try and move both m's to one side. We could do that, or we could move the 7, 13. It actually doesn't matter. Either way, you're going to see that this is going to come out to a special kind of equation which deals with another algebraic property that I'll get to afterwards. So let's take a look at this. Let's do the subtraction property, or the addition property, and add the opposite of m to both sides. Okay, I'm going to add the opposite of m. I'm going to add the opposite of m, and that's called the addition property. And I don't mind if students call this the subtraction property. If they're not well versed with algebraic addition yet, you may want to call it the subtraction property. And in fact, some teachers do separate the two into addition property, subtraction property. But under algebraic addition, it's the same operation. Okay, so take a look. I'm going to subtract m from both sides, and these are going to cancel on both sides this time, leaving with negative 7 is equal to negative 13. The opposite of 7 is equal to the opposite of 13. Okay, so what do we do? Is that a true statement? Well, no, obviously it's not a true statement. So for this one, what we write is no solution. Okay, there is no m that is going to make this true. No solution. Yeah, no m is going to make this true, and in just 1 second I'm going to show you the transitive property, which will help to explain this type of situation. Okay, have a look right here and see that I've rewritten problem 3 to include a y, another variable. Okay, now this is just going to be a placeholder, and if you look at it like this, you can see that m minus 7 is equal to negative 13 minus m. Okay, now what this is called the transitive property. This says if a thing is equal to another thing. Okay, so if m minus 7 is equal to y, and y is equal to the opposite of 13 plus m, then the opposite of 13 plus m is equal to m minus 7. In algebraic terms, let me just use something different. If a is equal to b, and b is equal to c, well, that means that, simplified, a is equal to c. Okay, we can kind of cut out the middleman. This is called the transitive property of equality, and it's an important thing to take away from Algebra 1. Okay, it means that we can throw in an extra variable, and let me show you why. Well, let's say I wanted to put this in my graphing calculator and actually graph this, m minus 7 without this. M minus 7 equals negative 13 plus m. Okay, so I'd have an m-axis and a y-axis. Okay, well, here's what we've got. We've got y equals m minus 7, and we've got y equals negative 13 plus m. Okay, now I'm going to take this second one, and using the properties of commutation or algebraic addition, it means that I can rearrange those numbers as m minus 13. Okay, what I want you to do is think back to Algebra 1 and try and remember something about slope. Okay, in other words, this is all in slope-intercept form right now. Y equals ax plus b. Okay, you all remember the coefficient on m is going to be the slope. All right, and you see on both of these equations the slope is equal to 1. So it has same slope, meaning that they're parallel lines, and we know that parallel lines never intersect. Okay, in other words, there's no solution for this, because a solution is where these two lines intersect. Okay, so if we looked at a picture of this on the graph, we'd have two parallel lines. They would never intersect, because parallel lines never intersect because they have the same slope or rate of change. And the first one would be, well, actually these are both negative, so it'd be below the line. Sorry about that. It'd be below the x-axis. Here's x, here's y, in this case it's m. Okay, so we've got two lines. We're down here in the negatives. This is, the bottom one is y equals m minus 13, because negative 13 is the y-intercept. The top one is y equals m minus 7, because it's above it, it's closer to the y-axis. Okay, or the x-axis. So you see that they're two parallel lines. Okay, that's called the transitive property. That's why there's no solution to that equation. Okay, this is problem number 4 on the quiz from Friday, and this says 12 times the difference between x and 7 plus 3 times the sum of 2x and 2 is equal to 50 times x minus 62. The reason for that is that's the problem I was given. I have to find an x that makes this a true statement. Okay, well, right here I'm going to have to do two different distributions on the next step. So I'm going to write distribution right here. Okay, so I'm going to go ahead and do these distributions, and for some people it helps to think of a distribution as doing one of these where you multiply, 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 multiply. Okay? Yeah, it's a little tough to see that, but it's there. Try and write it in blue. Multiply, 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 multiply. Okay? The reason I'm doing that is because I can't add x and 7. They're not like terms. I can't add 2x and 2 because they're not like terms. Okay, So here we go, I'm going to rewrite the next step. Okay, so that got just a little bit simpler there. Okay, so there we go with the distributions. 12 times 7 is 84, 6, 6, and 50, 62. Okay, carried down, all right. All right, good. The next step that I'm going to do is I'm going to combine like terms. They're on the same side of the equation, so I've got 12x and 6x are like terms, and negative 84 and positive 6 are like terms. Next, I'm going to combine like terms. I'm going to write CLT for combine like terms. Okay, so 12x and 6x is 18x. And negative 84 and 6, well, I showed you all a trick for this in my algebraic addition video. It's to just do this. You've got negative 84 and positive 6. And you're just going to find the sum of that, okay, which really, you're going to find the difference, all right, because they have different signs, all right. So I'm going to borrow 13, 12, 11, 10, 9, 8, and carry down to 7, and I was at negative 84, I went to the right 6, so I'm going to be at negative 78, okay, negative 78. Okay, no more like terms on the same side of the equal sign. So I'm going to start rearranging things. And the best way to do that is to look for the smaller one and move that to the side with the bigger one, because at the end we can just use the reflexive property to switch and get our variable on the side that's typical, which is usually a left. So here's what I'm going to do is I'm going to move the 18x over using the addition property or subtraction property if you prefer that. Okay, so I'm going to add the opposite of 18x, which is negative 18x. And this is I'm just going to call it the subtraction property for today. Okay, these two cancel. I'm going to carry down my negative 78. And 50 minus 18 is positive 32x minus 62. Okay? Looks like I'm running out of room. I might get one more step out of this. Okay, next thing I'm going to do is I'm going to move this 62 to the other side. Okay, so I'm starting to isolate my x on one side of the equation. Alright, so I'm going to use the addition property again and add the opposite of negative 62, which is positive 62, to both sides. Okay, so this side is going to cancel. Oh, sorry, this is the addition property. And 6, 1 in the negative direction. Okay? You guys see what I did? I took the difference right here, and I made it negative, as it should be. So I've got negative 16 is equal to 32x. Okay, right there I'm going to pause, erase the board, and keep going. Okay, I'm going to keep going right here. I've got negative 16 is equal to 32x. And the reason for this, I always like to write a reason. I usually don't write this particular reason, which is simplified. But I'm going to write it here just so I have something to start with. So this is the simplified from the last step. Okay? Now, what I need to do here is I know what 32 times x is equal to, but I need to know what 1x was equal to. So I'm going to use the division property and divide both sides by 32. Okay? So here's reason, division property of equality. And I'm going to divide by 32. Okay, so the 32s are going to cancel right there, and I'm just going to be left with x. And negative 16 divided by negative 32. We're going to put that in lowest terms, okay? The top and bottom, they share a common factor, which is 16. So I'm going to take out a 16 from each one. I may as well show that to you. I'm going to rewrite it, okay? This is negative 1 times 16 divided by 2 times 16, okay? Negative 1 times 16 divided by 2 times 16, and then the 16s cancel. So I'm just left with negative 1 over 2 is equal to x, okay? The reason for that was division property, and the reason for this right here was lowest terms. We can say that was our reason. Lowest terms. And here I have negative 1/2 is equal to x, and I can use the reflexive property to switch that around, put the x on the left-hand side, and say x is equal to negative 1/2. Reflexive property of equality. Okay? Okay, problem number 5, I believe we're on, says that we need to solve for C. We're given that 3/5 of the sum of 15C and 10 is equal to 12 times C minus 9. Okay, so I'm going to have to do a distribution first because I can't add unlike terms. Okay, so I'm going to distribute the 3/5 to this here that's in the parentheses. So the reason is distribution. And here we go. 3/5 times 15 is 45 over 5, which is 9C. And 3/5 times 10 is 30 over 5, which is 6. Okay, so now I've got the sum of 9C and 6 is equal to the difference between 12C and 9. Okay? Alright, next thing I'm going to do is move things around and try and isolate my C's. So I'm going to move my smaller one over. Okay, so I'm going to add the opposite of 9C to both sides. This is the addition property. Okay, so I'm going to add the opposite of 9C, which is going to give me, those are going to cancel. I'm going to have 6 is equal to 3C minus 9. Okay, the next thing I need to do is get this 9 over on the other side. So I'm going to add the opposite of 9, which opposite of negative 9, which is positive 9. Again, going to use the addition property. Actually, I'm just going to put it over here to the side so that I don't run out of room. Okay, 9 and 6 is 15 is equal to 3C, and negative 9 and positive 9 cancel. And next I'm going to use the division property to isolate C by itself. So this is the division property. Okay, the 3's cancel. 15 divided by 3 is 5, is equal to C, which tells me that C is equal to 5. That's the little transitive property right there. 5 is equal to itself. Okay, C is equal to 5. That was the answer to number 5. Okay, on to problem number 6. Right here I have 106 is greater than or equal to 19 times P plus 6 plus 6P. So let's sum all those three things. The reason for that is that was given. Okay, the first thing I want to do is combine like terms on the right side. I have 19P and 6P. I'm going to write CLT for combine like terms. Okay. Carry down my 106. Uh, 19 and 6 is 25. Okay. Next thing I need to do is move this 6 over. And I can do something called a transposition, but we're not worried about that this year. Transposition just means put it over here, make it negative, because it's positive here, change the sign. Not going to worry about that this year. I'm going to use the addition property and add the opposite of 6 to both sides. Sixes cancel. 106 minus 6 is 100. Greater than or equal to 25 times p. Now I need to know what 1p is equal to. I know what 25 of them are equal to, but just one of them. So I'm going to use the division property. And divide both sides by 25. Okay, 100 divided by 25 is 4. Greater than or equal to 1p. Okay, now, this is the important thing. I've got 4 is greater than or equal to p. Now, this part of this problem was to find the right graph of this equation. Alright, so I've got 4 is greater than or equal to p. Alright, let me erase real quick, come back and I'll show you the graph. Okay, so I've got my solution right here is 4 is greater than or equal to p. Now, what I need to do is use the reflexive property. Whenever I'm graphing inequalities, I want to have the variable on the left-hand side, and I'll show you why in just a second. So I'm going to use the reflexive property and flip these two things around, also being sure to flip my inequality symbol. Okay, so reflexive property. Okay, what I want you guys to notice is that when I flipped it, I also flipped the direction of the inequality. Okay, so what this says is 4 is greater than or equal to p, and that means that p is less than or equal to 4 by the reflexive property. Okay, you always have to remember to switch the direction of the inequality if you switch it. That was a common mistake on this problem. So let's check it out. Now what we need to do is graph that. Okay, so here's my number line, and I guess here can be 0, and this can be positive 4 in the positive direction. Remember, this is infinity, and this is the opposite of infinity over there. Now I need p less than or equal to 4. So, less than or equal to, that means 4 is included in this solution. Okay? If I had it just less than 4, 4 wouldn't be included in the solution. Because you say, I need less than 4 of something, that means you don't want 4. I need less than 4. Okay? Anything less than 4 will be fine. 3.95 will be fine. Just has to be less than 4. But in this case, 4 is included in the solution, so I'm going to color in my endpoint, showing that it's also included. Now, what I'm going to do is I'm going to draw an arrow, and that's going to show that all other solutions for p, all other points, okay? 3 is fine, 2 is fine, 1 is fine, 0 is fine, negative 1 is fine, negative 5,384 is fine, because everything that goes back in that direction is good. Okay? So you had to look for that particular graph on the solution to, I believe we're on number 6. Okay, last problem of the day from the quiz on Friday. This is problem number 7, and what this tells me is that I have 2 times x minus 5 times the sum of x and 3 is greater than or equal to the opposite of 21, and that was given. Okay, that's the problem. I need to find what x goes into this inequality to make it a true statement. Now, something about inequalities, always deal with them like they're equations, okay? The same properties of equality hold. I even wrote the properties of equality. It also holds for inequality. Now, the only thing you have to be worried about is if you multiply or divide by a negative number. And I think that comes up in this problem. Let's find out. Looking at it, I can't add x and 3 because they're not like terms. So I'm going to have to perform the distribution as the first step towards finding x. So distribution. And I'm going to carry down my 2x. Minus 5 times x is 5x. And the opposite of 5 times 3 is the opposite of 15. The opposite of 21. Okay. Next thing I need to do is combine like terms right here. I have 2x plus the opposite of 5x. Okay. So the opposite of 3x. All right. 2 minus 5 is the opposite of 3x. Okay, and the reason reason for that, combine like terms, CLT, combine like terms. Alright, next thing I need to do is I need to move this 15 in order to start isolating x and find just what 1x is equal to. Okay, so I'm going to do the opposite of the opposite of 15. I'm going to add that, which is positive 15. And that's the addition property. Okay, I'm going to carry down my negative 3x. 15's cancel. And 21 minus 15, remember I just do the difference. It's the opposite of 6, okay? So this says the opposite of 3x is greater than or equal to the opposite of 6. Now I know what the opposite of 3x is, but I need to know what positive 1x is. So I'm going to divide by the same coefficient that I have over here, which is negative 3. I'm going to divide both sides by that using the division property. Okay, negative 3 divided by negative 3 is 1. So I've got x. Now, here's the thing. Whenever I multiply or divide by a negative number, I need to switch the direction of the inequality. It's just something you need to memorize and always pay attention to. If I have a chance, I'll make a video that shows how that works. Now I probably have to. Alright, so just flip the sign of the inequality. And negative divided by a negative is a positive. So here's what I got. This is my solution. And I'll come back after I erase in 1 second and graph that. Okay, so here I have my solution is x is less than or equal to 2. Now, the reason why I always put the variable on the left-hand side is because if I look at the inequality symbol, I know which direction to go. In this case, it's less than 2. Alright, so less than 2 goes that way, and you can look at the inequality, it looks like an arrow that's pointing to the left. Okay? Now, it also includes 2 in the solution, so I'm going to put a solid dot on it. And then I'm going to draw the arrow to the right because all the solutions that are less than 2 will work for the original equation. Okay, so that's it. That's the solution in number 7. I'll come back in a second with the video for the reason why you flip the sign of the inequality when you do a negative number. Okay, so this is why we always flip the direction of the inequality sign if we multiply or divide by a negative number. Let me start out by showing you this inequality. It says that x is less than 0. So here I have my graph of the equation, and it says that here's 0, and there's positive infinity over there. Here's negative infinity over here, and I'm going to graph x is less than 0. Okay, so in my infinities, the opposite of infinity. Okay, I'm going to put an open circle because this does not include 0, and then I'm going to go to the left. So that right there is the graph of x is less than 0. Okay, now what I'm going to do is I'm going to throw out the opposite of that. Okay, let's say that I multiply both sides by negative 1. So negative 1 times x is negative x. And here's 0. Now look, this over here is x. Okay, these are all the x. It's less than 0. Now, I want the opposite of that. Alright, the opposite of that is everything that's over there. You guys see? Here's x. Over there is the opposite of x. Remember, the opposite just means we're going to switch sides over 0. Okay, we're going to switch the sides. Alright? Here's negative 5, and the opposite of negative 5 is over here. Okay? So here's x. Now I'm going to do the opposite of x. Now, if I graphed this and I didn't change the sign, I would say the opposite of x is less than 0. But no, that's x. If I put this sign in, okay, what I would do is I'd graph a 0, and then I'd do the same thing, go to the left. But no, this is the opposite of x. So what I need to do is flip the sign to make it go in that direction. This says the opposite of x is greater than 0, which would go in that direction. Okay? Here's x. is less than 0. This is the opposite of that. The opposite of x is greater than 0. That's the reason that you need to flip the sign if you multiply or divide by a negative number.